I was present in yesterday's sessions, and all those sessions were very insightful. And I felt like, although I have been away from India for about 7 or 8 years, I think through such conferences and summits, I have been keeping in touch with some of the water quality issues and some of the developments in the water sector. So thank you for again giving me the opportunity. So sorry, can you go back to the first slide? Yeah, the next one. Yeah, so I've covered everything. I just wanted to highlight the bolded part. The 1.5 years I've spent at IIT Bombay as a professor, we actually did some study on the water quality. And so what I'm going to do a little bit later on is do some comparison with 3 countries, the US, New Zealand, and India. So the next one. So I'm going to talk a little bit about New Zealand, and I guess when we talk about New Zealand, probably the image that comes through is very clean and green, right? And I think some of the pictures, if I just Google this, these are the images that are shown. I'm not saying this image is false, but there is also conscious efforts from the New Zealand government to actually keep this image going. So the mentality in New Zealand has been that, well, we have been perceived as clean and green, and our environment is perceived as clean and green, so keep maintaining that thing, right? Because for New Zealand, tourism is a major industry, and also their agricultural products and meat products are considered quite premium. So they sold it at a premium price just because they are from New Zealand. So for example, China is the major buyer of the products. So it's in the government's interest to show that, well, we are cleaner than the rest of the world. We have the less pollutants in water, less pollutants in air, less pollutants in soil. So there is an interesting case that happened because we did this study in water pollutants in 3 countries, right? In America, when I just finished my PhD, we approached the county and said that we want to look at some of the contaminants like pharmaceuticals, personal care products in your wastewater. And they said like, oh yeah, sure, let's do that. Not only we will give you samples, but we'll give you money to analyze the contaminants. So that's the forward-thinking way, right? Then when I was at IIT Bombay, we went to the same way to Mumbai's wastewater treatment plants. And they are like, okay, if you want to do the study, you are more than welcome to do the study. We can't give you money, but whatever you want to do, do it. You know, and so that's also still good, right? Because we were able to do some of the work. When we went to New Zealand, they said like, why you are looking for problems in our water, right? We don't want to find the problems because, you know, we are really happy with our image that we are completely satisfying the regulations. So they are not only they are not forward thinking, they are actually blocking our path to actually understand where the issues are. And as we were discussing yesterday, if you don't know the problems, you can't improve anything, right? So finally, we were able to go through that phase and actually find out alternate way to carry out this study. And what we found out is that the environment, the New Zealand environment, is not as clean and as green as government would like you to believe. Okay, it's still cleaner, and I'm not saying that it's bad, but what I'm saying is that there are a lot of issues there as well in the water quality. So the bottom 2 pictures are one from Auckland, the largest city in New Zealand. 1/3 of the population is in Auckland, so that's where University of Auckland is, which is the bottom right picture, and that's where my lab is, and that's where most of the work that I have been going to show you has taken place. So next one, please. So I'm not going to go too much in detail. I think you have seen this in many different formats. Our earlier speaker also, Mr. Suryam, actually referred this, that 97% water is in sea, only 3% is of fresh water, but out of 3%, less than 0.7% is available to us, right? So it's very much a fraction of the water that we are looking at. And in that sense, we need to understand why water conservation, the theme of this thing, is quite important. Because what I'm going to show you is that wastewater reuse, I kind of slightly disagree with earlier speaker in some ways, and I'm going to a little bit highlight that. But also I agree with him on many other points. But what I would like to say is that with our current lifestyle, wastewater reuse is not as appealing as maybe water conservation and some of the reuse of grey water or storm water that we are going to look at. So next slide, please. So because this is the World Water Summit, I thought like we have been focusing a lot on India, and I think of course it's important to understand the challenges of India. And we saw in yesterday's talk about water stress levels in India, that the river basins in India are quite stressed. Some are going to that category of not only stress but water scarcity part, right? So if you look at the world, and this is a projection in 2040, the water stress is going to be there almost everywhere. Only there are a few countries, New Zealand is one of them, but most of the other countries, as you see, the bigger countries particularly, are going to be water stress. So we have to look for some solutions either way, right? Either the reuse, recycle, or conservation and treatments, advanced treatments and so on. So this, so hopefully the next slides will give you a little bit more information about what are some of the challenges about the reuse. So next one, please. So this is the status of the global wastewater reuse, and we have been focusing a lot on it in yesterday's session. As you can see, this is not per capita, so this is not normalized. So if you look at just the treated wastewater flow, US is leading because the total volume, and then what the other countries, if you can see or read on that slide, are mostly from the Middle East, mostly water stressed countries, as we already know it, semi-arid countries. What you don't see is that probably India could have been there also as well, considering that how water stressed some regions of our country are. But in some ways, as I will be pointing out, there are maybe other ways we can go around that challenge of how to get the fresh water. Okay, the Singapore, one of the notable exceptions is Singapore, and that's because it's such a small country that you don't see it here. But if you normalize it per capita basis, you will see Singapore there in top 3 or top 5 countries. Okay. So next slide, please. So what's the current status of wastewater reuse? There are about 5,000 water reuse facilities around the world which are practicing wastewater reuse, and it's divided very equally, sort of thing, in the sense that there is a wastewater reuse market for irrigation, of course, there is a wastewater reuse market for indirect potable reuse, there is a very, very small percentage market for direct potable reuse. And we will see why that's the case. You know, it requires a lot more challenging technologies to actually have that, so the water becomes costly. As our earlier speaker was saying, maybe the desalination in that case might be a better alternative. But even with all these advancements, only 5 to 7% of wastewater is currently reused. Okay, so just keep that in perspective of how much wastewater gets actually treated. So nowadays, the current figure estimates is that in the world, 50% of, almost 50% of wastewater is getting treated, some kind of treatment, primary, secondary, or something like that. But out of that, only 5 to 7% of the wastewater is actually reused. What I'm going to show in the following slides is that wastewater reuse has certain limitations, and the technologies can become quite challenging if you look at some of the contaminants that are present in wastewater. So in some ways, it makes a lot more sense to reuse the grey water or reuse the stormwater runoff. And what we haven't been seeing in this conference a lot is the third water. So I particularly specifically put the title of the presentation as 3 waters, because it's the drinking water, wastewater, and the stormwater, right? And stormwater management is quite lacking, particularly in India, and that's something I would consider as an untapped potential source of water reuse if we can give technologies that requires a lot less technologies or advanced technologies compared to the wastewater. Okay, so we'll talk about that. I just want to see the show of hands in terms of grey water. How many people actually know grey water is? Not really, maybe one person. Yeah, so the grey water, when I say grey water, is something, a concept that has emerged over the last 15-20 years. It's instead of wastewater, what some of the countries, some of the developed countries are now doing is they are separating the water that comes out from sinks, bathrooms and so on, and keep the toilet separately. So the toilet is considered black water, and then the other rest of the water, whatever comes out from the kitchen sinks, washing machine, whatever comes out from the bathrooms, you can keep it as a grey water. And it makes sense on so many levels, because wastewater treatments, anyone familiar with wastewater treatments knows that wastewater treatment is most effective, biological treatment is most effective when it's concentrated. You know, if it's a lot of organic matter concentrated, then it will become a lot more effective. While if you dilute it with all this sink water, bathroom water, which is the case in many places around the world, then the treatment efficiency also decreases. And the second point is that if you separate this water from the toilet, then it's much easier to treat this water, because this water has a lot less pathogens and lot less contaminants, as we'll see. So it becomes much easier to treat the grey water than to use this as a combined sewage. So there is a lot of potential on that, but in this presentation I'm mostly going to talk about the contaminant sites on the wastewater. So the next slide, please. Alright, so all of us are aware, and I think maybe I wanted to take a step back in this presentation and actually present a bigger picture in terms of the contaminants itself, like what kind of different classes of contaminants exist and why some of the reuse can be a challenging thing. So as you probably see this cycle, right, like most of the things fade to the wastewater treatment plants. And so if you look at some of the contaminants and their major sources, wastewater is always mentioned as a major source to the environmental pollution. So the wastewater discharge is always mentioned as a major source of, say, for example, microplastics, or for, say, pharmaceuticals, and so on. So it is really critical for us to understand how all this is connected, because the conventional water and wastewater treatment processes were never designed to remove these contaminants that we are seeing in the modern life. The chemicals that we are experiencing, the pharmaceuticals, personal care products, as we are going to see, or some of the pesticides and things like that that we are using in daily life. And if you know, all the water is connected, right? So it's actually the one water. And if we use contaminants and those get washed through wastewater, there is always a potential of those ending in our glass of drinking water through this water cycle. And as I said, because the conventional treatment processes are not effective, your wastewater won't remove those. So in the effluent you see these concentrations, which I will show some of the results for. And similarly in drinking water, even if you are taking the water from, say, river or ponds or lakes, you will see that many of these contaminants are only partially removed through water treatment processes. So the next one, please. So taking a big picture view of the contaminants present in wastewater, you can classify those as traditional contaminants and emerging contaminants. And when we talk about wastewater treatment itself, that was designed primarily to remove use chlorine. Then we are going to see a lot of DBPs in our water. But we will go one by one of each contaminant, and I will a little bit explain what are some of the challenges with these contaminants. So the next one, please. Yeah, so let's look at the pharmaceuticals. And we take pharmaceuticals when we are sick, right? So this question for a lot of people is that, why would it matter if we are drinking the pharmaceuticals at a concentrations like 1,000 times or 1,000,000 times lower than the concentrations you are taking when you are sick? So there are two issues here. First of all is that when you throw away the pharmaceuticals, or when the pharmaceutical washes from your body through urine and feces in the wastewater, it's not the single pharmaceutical that's present now, right? It's a mixture of different pharmaceuticals, chemicals. And it has been shown in the laboratories that if you actually combine 3 or 4 different chemicals, then the effects, the toxic effects of some of the chemicals can exponentially increase. So what the danger is that in our water, now you have the cocktail, as we call it, cocktail of the pharmaceuticals, mixture of pharmaceuticals present. So it's not only one pharmaceutical, but you have different pharmaceuticals present. And the second thing is that because they are present in our drinking water glass, we are drinking those every day, as opposed to being sick and taking it when we are sick only, right? So you don't know the effects of taking something over, say, 20 years or 30 years, as opposed to taking it only for 3 or 5 days when you are sick. So it is a concern, because most of these pharmaceuticals are very poorly removed during the conventional treatment processes of water and wastewater. There are advanced treatment processes that can remove many of these contaminants, many of these pharmaceuticals. But as you are aware, in India, in most of the wastewater treatment plants, they are mostly restricted till secondary treatment, right? So what we are seeing is a lot of concentration load of pharmaceuticals in surface water bodies and in coastal regions of India. And I will show you a figure for one of the surveys of Mumbai's wastewater treatment plant. The next one, please. The next category of emerging contaminants is the personal care products. And we use so abundantly some of these products like soap, toothpaste, deodorants, shampoos. And if you look at any of their labels on these products, what they say is that don't ingest those, right? It's only for external use. But if you actually use those, it goes into our wastewater treatment, again, very poorly removed, ends up in our wastewater effluent. What we have been seeing is that these pharmaceuticals and personal care products actually end up in our glass of drinking water. So we carried out the survey of drinking water in the US with advanced wastewater treatment plant and advanced drinking water treatment plant, and we still saw out of 30 pharmaceuticals and personal care products we monitored, we saw about 20 of those ending up in our glass of drinking water. So you can imagine, if our drinking water treatment plant, which does not have some of the advanced treatments, we might be seeing probably higher concentration here in India. Next one, please. I'm going to group some of the other chemicals, such as pesticides and the plasticizers, for example, you may be aware, into a class called endocrine disrupting compound. And the reason this class of chemicals is quite important is because they mimic the hormones in our body. And once they get ingested in our body, even at low concentrations, our body will start showing very different effects. For example, in fish, what they have been saying is that male fish showing the female organs and so on. And so that's why these compounds are called endocrine disrupting compounds, because they disrupt endocrine system. And they are present in all these products that you are seeing the picture of, the non-sticks, you are seeing the rubbers, the plasticizers. Many of the plastic bottles 5 or 10 years ago used to contain a compound called bisphenol A or BPA. And bisphenol A is the primary endocrine disruptor. And that's why companies now have started moving away from BPA, and on many of the labels you will see it's a BPA free. It's because of this activity, endocrine disrupting activity. The next one, please. So, as I said, we carried out this survey of pharmaceuticals, personal care products, and endocrine disrupting compounds in 3 different countries. But I'm only showing the results for Mumbai's wastewater treatment plants. So we did it in 2 wastewater treatment plants in Mumbai. And as you can see, the concentrations are quite high in microgram per liter. It's quite high considering some of the toxicity levels of these compounds that have been established in the lab. So what I have been saying is that in Mumbai, it's a bit fortunate because it's close to coastal water, right? So you can dump your sewage into the ocean and may not directly see the impact of the things that you are doing in a long term, or at least in a short term. In the long term, it probably will come back. But in a city like Delhi or landlocked cities in India, there are plenty of those. What happens to this effluent is that these get mixed with the rivers or the surface waters. And as I was saying, the drinking water treatment plants are generally very, very less efficient to remove these compounds. So what you see in the effluent, about 20% of that or 10% of that will end up in our glass of drinking water if there is a pathway for drinking water through the wastewater effluents. This next slide. I mentioned disinfection byproducts, and again, this is something that has to be now looked at in India much more carefully, because our primary aim for drinking water and wastewater is pathogens. So the practice for most of the treatment plants here is to put chlorine, probably even slightly in excess amount, so to make sure that people are protected from pathogens. But what the side impact of having chlorine or excess chlorine in water or wastewater is that chlorine reacts with organic matter that's present in our water and wastewater. And it forms compounds like nitrosamine. Again, don't worry about the chemistry, but these compounds are highly cancer-causing compounds at concentrations like nanogram per liter level, which is 10 raised to minus 9 gram per liter, which is a very, very low concentrations. What we are saying is that these compounds are present at a higher concentration than those for which their 10 raised to minus 6 cancer risk level has been established, which means that it's dangerous, basically, in short takeaway. But disinfection byproducts is something that hasn't been monitored very well in India, most of the places, and this is where we really need to pick up, because in the glass of drinking water we are having, there is actually direct reaction of chlorine and organic matter, and what you see is some of the tests you are experiencing is not from only chlorine, but it's the chlorinated disinfection byproducts which are also toxic. Alright, so the next one, please. Alright, so if you have been following a little bit of water quality news around the world, currently the most hot topics in water quality are PFAS, which are called forever chemicals, and second one is microplastics. And I think most of you are knowing microplastics, right? But probably very few of you have had this term of PFAS. The reason PFAS are getting a lot of popularity is because these products were actually designed 60 or 70 years ago to last forever. So they have the carbon and fluorine bond. Again, chemistry is not important, but this carbon and fluorine bond is one of the stable bonds in the environment, and it's very difficult to break down with the treatment processes. Forget about conventional, even the advanced treatment process like UV or advanced oxidation processes with radicals, it's very difficult to break down these compounds. Where are these compounds used? Everywhere you can think of. Like they are used for fire-resistant foams, they are used in places where you need water resistance, stain resistance, carpets, clothes, etc. And many of these compounds end up in our glass of water because they are present on our sofas, carpets, the water-resistant jackets we are wearing, and so on. And as I was saying, many of these compounds have been established with their toxicity in nanogram per liter level. And there are 9,000 compounds. So just imagine how difficult the challenge is to even monitor some of these compounds. Next slide, please. So again, you don't have to look at this one. But the key message for PFAS is that we have been monitoring PFAS in New Zealand. And New Zealand is considered one of the cleanest countries when it comes to these forever chemicals because they have no PFAS manufacturing industry. And still we are seeing the concentration of PFAS in their wastewater. So just imagine for India, where we have the 3M and DuPont India making some of the PFAS-laden products, like what will be the concentration of these compounds. But this issue, again, is one of those issues where we really need to pay attention now. The disinfection byproducts I mentioned, the PFAS, and also some of the pharmaceuticals and personal care products challenges. The next one, please. I think I'm not going to talk a lot because I think there has been a lot of talk about microplastics in yesterday's session, and I think people are aware, but what I just want to say is that World Health Organization came back 3 years ago saying that microplastics, if you ingest by themselves, are not really harmful. So microplastics just getting in your body is not going to do much through a glass of drinking water. But what is the issue here is that microplastics are also good in absorbing the contaminants in the environment. So they are a vector, so they will carry along with them some of the toxic chemical, or they will concentrate some of the toxic chemicals in the body, and that can be very harmful. And so that's the reason for the concern on microplastics. The next slide, please. Why it's lacking, the emerging contaminant research is lacking in India, and why it is not really looked at very well is because it requires very highly advanced laboratory. So the instruments can be $1 million instrument just to analyze this contaminant at the concentrations I have been talking. But the reason it's important to analyze these contaminants at those concentrations is because they are present, their toxicity is as low at the concentrations that requires for the analysis. The next one, please. Yeah, so just the key message to end up, it's the contaminants are documented well over 50 years, but what we have been seeing is the change in profile of contaminants. So from traditional contaminants, now we are moving towards emerging contaminants. There are always technologies that are available to remove these contaminants, as our earlier speaker, esteemed speaker, has mentioned, that you can actually treat the contaminants. But what you need to analyze is the amount of energy that you are putting in. Is it worth the benefits, right? So that's why that message of water conservation becomes very critical, because rather than producing the waste and dumping it, and putting a lot of energy, it might be easier to produce less amount of waste in the first place. And even the gold standard like reverse osmosis, which has been touted to remove some of this contaminant, just keep in mind that you still have to deal with the waste, right? Reverse osmosis does not destroy the contaminants. It just makes the water on the other side of the membranes clean, but all the contaminants and the toxics get accumulated on the other side. You still have to deal with the reject. So it's a lot of cost-consuming technology. So I think with that I will just wrap up and say that thank you again for giving me the opportunity, and I will be available after the session if anyone wants to discuss the contaminants. Thank you again.